gametes? How many in a man? How many for a woman? What else is produced instead of a gamete? So there's
Polar
polar body. Can they be fertilized?
No.
No. We don't have enough cytoplasm. Products of the beginning and end of each stage of meiosis. So you need to know exactly when you go from haploid to diploid.
So the third stage.
Give it a name.
Meiosis 2?
Nope.
No.
It's in one. It occurs in one. Why? Because you're splitting homologous chromosomes. So the whole chromosome goes apart. Alright? It happens in anaphase 1. They come apart. You're now dealing with the potential of a haploid cell that continues on through telophase. Okay? Be able to identify all stages of gamete production in the ovary model, which you guys all looked at, right? Mm-hmm. You know where all the structures are, and you know where to find the key. Key should be in your lab. Okay? Know that. You can ask questions like the timing type question, okay? When do you start producing primary follicles?
For women?
Well, they only occur in women.
Shouldn't that be 6 to 7
Beginning of
days?
what?
6 to 7 days before ovulation?
No, you start those as a fetus. You're born with those. You arrest in metaphase 1. That is why women, as they get older, are more prone to non-disjunction. Because that machinery's been sitting there. If you're 40 years old, it's been sitting there for 40 years. Which means you have potential of degrading some of those spindle fibers. Things don't pull apart correctly. That's why there's an exponential increase once a woman reaches about 35 as to the number of non-disjunctions she'll produce. Right? It's all in the timing. You should be able to explain to me what that timing is. And if you can make the correlation to non-disjunction, that'd be really good. All right? Any more questions? Mitosis and meiosis in men and women, it's the subject. We're going to hit it again, too. Any more questions? Okay. This is kind of overload, huh?
Yes.
All you thought you knew but didn't.
So she did 3 chapters.
Graphing. So lab 1, be able to graph a data set. She gave you a data set, right? And she wanted 2 y-axes. She can do that. You need to know what goes on the y-axis. What goes on the y-axis? The dependent, what is the dependent variable? How do you recognize it? What you measure. If you're measuring temperature, temperature goes on the y-axis. If it's glucose levels go on the y-axis. By and large, time is always your independent variable that goes on the x-axis, but it can be other things. All right. Titles, what you must contain in your title. You must have what you have on your y-axis, what you have on your x-axis, and where you got your data. Those are the 3 things that need to be included in your title. That's what I'm looking for. Scaling, and this is kind of where we're going back and forth. Use the range of data that you establish. And the range goes from the high point plus 2 to 3 more, low point 2 to 3 less, depending on what makes it easier for you to scale. In the middle is your set point, but this time use the median of the range. If you use the median of the range, then your scaling should be the same on both sides of the set point. Does it make sense? Okay.
So, Doctor, when we did it last week, in regard to
Yeah, we use the average.
right, and that really didn't work out.
You can use the median.
Okay.
You don't have to turn it over until next week. So.
Yeah, no, I changed mine to the median because it just
Yeah.
didn't work out that way. So okay.
Change it to median. y did for the x. What's your range on the x-axis? What's the middle point? Use as much of the x and y-axis as you can. Do not put data points on the last lines. With the exception is you can't have a data point on the y-axis. Right? Don't forget your label and your units. A label is what you're measuring. The unit is what degree or what you're measuring it in, whether it be degrees, grams per deciliter. Those are all units. The only other thing is the origin, which I don't have up there. It's generally understood. Where's the one time where you have 0 at the origin? You use the spec.
It's when we got 0 when we set it.
Right,
that,
but what kind of graph is that?
That's a
Standard curve. So for a standard curve, I must see a 0 at the origin because you measured it for both. If you only measure it for one and not the other, don't put the 0 there. 0 is understood. All right? So any more questions on graphing?
So on this one that we just did, we shouldn't have a 0 down there on the time because we
Did
took a
you-
measurement at 0.
Right, but did you measure a 0 glucose concentration? No, you have a dead person. So, yeah, it can't be
I
there.
didn't put that. Okay.
For most of the things you're measuring on volunteers, there's no 0. Unless you physically measure it for both the x and the y-axis, then you can have a 0 there. Standard curve is a special case. It's actually used as a measurement. Your homeostasis model, be able to use a homeostasis model to predict how the body deals with changes. So, that model that she gave you at the very beginning, yeah, you need to be able to label it, given what she gives you in the problem. So she has to give you an idea of what's going on in the body, what the set point was, or at least a way to figure out what the set point is, what the disturbance is. And they're generally word problems and you're just picking out information. You need to know how to determine the range, and from the range you get two values. You get error and you get feedback element. Always remember, feedback element is a value, it's not a description. You need to know what the effector is. Well, okay, the sensor and the control element. Control element is either nervous or endocrine system. One of the two. If you're working with the endocrine system, make sure you have, if your hypothalamus is part of the endocrine system. Okay. Effectors, you need to know what happens after your effectors start working. What you're outputting, so what is the change that occurs to bring you back to your set point? That is output. And then feedback element. All right? Any questions on that? Oh, and disturbance. Sometimes disturbance is given, sometimes it's not. If it's not given, then you're working within the normal range. If it's given, then you would put that above your set point. If it's only going in one direction, that's an example where you'd only go in one direction. If she gives you the disturbance, a lot of times she doesn't. She expects you to know that you would go within your normal range. Any more questions? The homeostasis model, once you get used to it, you can use it for your feedback loops, okay? Because essentially it's the same information, but now you're actually showing her a little bit more of the process. So here you have a lot more words. You're describing what is the sensor, control, effectors, and output. And where you generally have more input is in this output and effect. So learn one, you learn them both. And remember, for a feedback loop, you need to go in both directions unless she gives you the disturbance or if the range goes only in one direction. Any questions about that? Those, once you get used to them, are pretty easy, and you will see these throughout the whole course. You don't forget them here because you'll see them again after midterm. Some stuff you don't see after midterm. Chemistry and solubility, being able to distinguish between hydrostatic pressure and colloidal osmotic pressure. Okay, with colloidal osmotic pressure, you need a protein, which is generally albumin. So it keeps interstitial fluid interstitial. Be able to use Beer's law to determine concentration using absorbances. Be able to use data from absorbances of standards to construct a standard curve. Yeah, she can make you do the standard curve. She can also give you the unknown and ask you to use the standard curve to estimate or calculate its concentration. Right? So besides using Beer's law, you also have to know there's two methods. One is Beer's law, the other is using a standard curve. You need to be able to use the spec. When you use the spec after each student, I will be changing things on it. So don't assume that the person before you did it right and you're just going to use what they did. So the steps that you need to do, first of all, you check the wavelength. The wavelength should be written there. So always make sure that your wavelength is correct. Then you would go to your blank, clean it, wipe it down. When in doubt, wipe all your tubes down. Okay? You don't want to measure fingerprints. You put that in and you zero it. You zero it only by using the knob on the right. Do not use the knob on the left, you will turn it off. Or you won't do anything. Okay? So if I see people playing with that knob, I will tell you to go sit down and think about it. Okay? Think about it, come back and try it again. Let's see. Be able to identify appropriate places to throw waste, and that's in that lab. It gives you directions as to where you throw hazardous waste. So look at that. Anybody think of any more questions on this one? Osmosis, calculate percent increase. So if percent increase is on the y-axis, what's on the x-axis?
The number.
It's not time.
Concentration.
Concentration.
Concentration. All right? You have two different concentrations. Be able to graph data for changes in weight of a dialysis bag due to osmosis. Be able to describe the process of osmosis and determine the direction that water will move given the concentration on either side of the membrane. So this is where you can draw the arrows. So you need to know what's hypertonic in relationship to the other solution, or what's hypotonic. Any more questions on osmosis? No. Karyotypes in genetic disorders, you'll be able to identify the defect on karyotype. So she gives you the normal karyotype. What your question will be if the karyotype is something abnormal. You need to be able to identify it. I also need to be able to give me a name for it. A hint, and this is a big hint, is that generally what you see for in a karyotype for a genetic disorder is non-disjunction. So you have 4 examples of non-disjunction. Well, yeah, 4. 4 or 5, depending on if you're going to count the X chromosome once or twice. You need to know the names for them. You need to know what trisomy 21 is. What is the name for that?
Down syndrome.
Down syndrome. What about trisomy 18? Trisomy 13? Monosomy for the X chromosome. Those are what you need to get off that list of karyotypes.